Hello and welcome to Ceasefire's Advanced Intelligence Center. Ceasefire is today India's most trusted fire safety brand and is trusted by over 5 lakh of our customers in India and the world. Ceasefire today has over 400 life-saving fire safety and security solutions spanning through all aspects of fire safety and security. Today our range includes products from fire extinguishers to special application fire extinguishers, specialized suppression systems, micro-environment suppression systems, and kitchen fire safety solutions.
Products aren't just manufactured as Ceasefire, but are engineered to perfection. Every Ceasefire product conforms to highest standards and carries international quality certifications. The reason behind this is simple. At the time of need, our product has zero tolerance for error. Do you know that a Ceasefire product is used by somebody in real life situation every 5 minutes?
In this facility, which we call as the Ceasefire's Advanced Intelligence Center, crucial information and knowledge on fire safety is disseminated to the world. We believe it is this knowledge that can make all the difference in any fire emergency or security breach situation. In this short film, we shall try to answer for you some very important questions around fire safety and how you can make the best use of your Ceasefire safety product that you have invested in. Here we shall try to answer questions like 1. What is fire? 2. What terminologies are associated with fire? 3. How does fire spread? 4. How to approach fires? 5. How to hold your fire extinguishers? 6. What precautions to take while firefighting? 7. How to extinguish fire? 8. How to maintain your fire extinguishers? And 9. We should also try to explain how to install your fire extinguishers. Before we begin with any of the specifics, let us first try and explain you what is fire. What is its composition? What are the terminologies associated with fire? What are the classes of fire and their significance? The stages of fire and how fire goes exponentially. A fire is best understood by using a triangle in place of a fire, where each side of the triangle represents fuel, energy and oxygen. If we were to remove any one side of the triangle, we will not have the triangle. That's no fire. The concept of fire triangle representing the 3 basic constituents of fire is a conventional concept. There is a 4th constituent in all flaming fires that plays a vital role in the growth of fire and its sustenance. As a result, a step further in the concept of fire triangle is introduced a concept called fire tetrahedron. The concept of fire tetrahedron introduced one more element in the addition to the 3 elements explained in the fire triangle. This additional element is an unbroken chain chemical reaction to the existing 3 components explained in fire triangle. Once a fire has started, resulting in an exothermic chain reaction, sustains the fire and allows it to continue until and unless at least one of the elements involved in the fire tetrahedron is blocked or removed from the picture. In the fire tetrahedron, each of its 4 sides represent one of the 4 basic requirements: fuel, temperature, oxygen, and unbroken or uninhibited chain reaction. This last factor comes into play only in flaming modes of fire, which is normally applicable in the case of flammable liquids and gases. In the flame front, due to the chemical reaction, active free radicals of hydroxides, hydrogen and oxygen species are produced with act as a catalyst in the chain reaction. This further helps to sustain the flame. The Extinguishment of fire by flame inhibition or breaking the chain reaction is achieved when these active free radicals or chain carriers are inhibited or eliminated. This principle of fire extinguishment is known as breaking the chain reaction. This is achieved by the removal or suppression of free radicals. The extinguishing agents used to this purpose are halogenated hydrocarbons or halons or halon alternatives and several types of dry chemical powders. On application of these agents, the flame becomes inhibited and extinguishment is achieved. Each of our firefighting solutions quell the fire by suppressing or eliminating either one or more of the elements in the fire. Now, having understood the concept of fire tetrahedron and how the concept also helps in us understanding how fire can be extinguished, let us now move on to understand some of the important facts on fire as they play a big role in the field of firefighting. Let us now redo the above experiment, this time without removing the paper or flame. Do you observe any difference? If you keep the paper at the same point, the heat is sustained and the paper catches fire. This point at which the paper catches fire is the ignition point for the paper. Here again you should understand that the different materials have different ignition points. It is actually the point where the moisture of water content of the substance evaporates completely, making it hot in the presence of oxygen or the substance of fuel starts burning. First important fact to understand about fire is flash point. Flash point is the lowest temperature at which the substance or fuel forms ignitable mixed with air. Let us understand with the help of a small experiment. Example by demonstration. Take a piece of sheet of paper and place it over a burning candle. Wait for a few seconds. You notice that the paper starts changing color. At this point, if you remove the candle or take away the piece of paper from the flame, the paper ceases to catch fire. This point is called the flash point. When the substance is on the verge of catching fire, flash points vary with different materials. Let us now redo the above experiment, this time without removing the paper or flame. Do you observe any difference? If you keep the paper at the same point, the heat is sustained and the paper catches fire. This point at which the paper catches fire is the ignition point for the paper. Here again you should understand that the different materials have different ignition points. It is actually the point where the moisture of water content of the substance evaporates completely, making it hot in the presence of oxygen or the substance of fuel starts burning. Now we come to flashover. First of all, please understand that flash point and flashover are two different stages of fire. We have already discussed about the flash point. So let us now understand what flashover is. Imagine a typical room full of various types of materials. Keep a burning object there and wait for a while. There comes a point when most materials inside the room start burning simultaneously. This is called flashover. This occurs as most of, if not all, materials reach their ignition points. The reason is the heat supplied by one burning material present inside the room in the presence of oxygen and free radicals. Also notice that different materials burn at different times. Having discussed the basic facts related to fire, let us now move on to the class of fire. Various classes of fire have been recognized based on how a particular material or group of materials react to fire and how easily it catches fire. Class A fires are fires involving common solid combustible material like wood, paper and cloth. Such kinds of fire require heat removal for extinguishment. Best known extinguishers are water-based. Class B fires involve flammable liquids and gases. Example, kerosene, petrol and alcohol. These have definite ignition temperatures are in the range of 50 to 250 degrees centigrade. The with fuel vapor catching fire. Best way to extinguish fire like this is to use a blanketing effect with foam-based extinguishers. Class C fires are fires involving gases like LPG, methane and CNG. Cutting off fuel to flame, for example, using water-based equipment is a good way to extinguish such a fire. Class D fires are fires that include combustible metals such as magnesium, aluminum, zinc, sodium, potassium, etc. These fires require special agents for extinguishing. Required is that these agents form a crust on top of the fire, smothering the fire. Ranges are from 0 to 600 and 600 above degrees centigrade. Class E fires are those that are triggered off in the presence of electricity. Most often it is termed as electrically started fires or ESF. ESF is the chief cause of fire accidents. We can also say that ESF is a source of fire rather than class of fire. These kinds of fires, please avoid using water-based equipment. Class F or K series fires. When cooking oil is superheated, it starts giving out highly flammable gases or fumes. These fumes catch fire instantaneously as the ignition point is lower than that of the oil itself. They differ from B class such that the fuel itself is very hot, that is in the excess of 350 degrees centigrade. Extinguishment here would require cooling or smothering using water mist or wet chemical, respectively. Understanding the concept of various classes of fire also helps us understand in segregation of firefighting techniques suitable to a particular fuel. It also helps in understanding and distinguishing between extinguishing agents that are suitable to fight various types of fires. This is important as an incorrect extinguishing technique used can cause more harm than help. For example, if water is used to extinguish a B-class fire, oil being lighter floats on water and continues to burn and might even spread. On the other hand, using water or stream of water on electricity would cause short circuiting or electrocution. Another important thing to learn about fire is the stages of fire. What are the stages it follows while it grows and how fire grows exponentially. The stage of fire helps us understand how the fire spreads rapidly in terms of coverage and intensity. It also makes us understand the use of various fire safety devices for each stage of fire, from early warning system to fire extinguishing technique, and most important, evacuation. It also explains us why early detection is such an important word in firefighting. We have 3 stages to fire. Stage 1 is the incipient stage. This is the right stage for detection of fire, where the material which is about to burn gathers on heat and goes for flash point. Stage 2 is the critical stage. Fire moves and grows rapidly. Portable as well as trolley mounted fire extinguishers can fight the fires at this stage. Here the flame has got on and the fire starts spreading by various means. At the end of this stage, stage 3 starts. Here, the blaze stage, where only water mist, hydrants, sprinkler systems and the fire brigades can go. And the fire grows exponentially and uncontrolled. To understand the various stages of fire, we need to understand the spread of fire. Fire spreads by 3 methods. Initially, conduction, convection and radiation. In conduction, the heat moves atom to atom from one point to another point. As the fire starts, a convection current is rolling. This convection current is the rise of heated gases and cold gases taking place. Third is radiation. Heat movement through the photons emitted through fire. Good example of radiation would be sunlight reaching Earth through no medium. Firstly, we need to observe the spread and class of fire and choose the suitable fire extinguisher accordingly in size and type. Secondly, we need to make sure that the fire does not block the firefighter's escape route so that the firefighter does not get trapped in case the fire goes out of control. Thirdly, keeping the second point in mind, we need to approach the fire mostly from the side where the flames are going away from us. This makes sure that maximum of the extinguishing falls onto the fire and the visibility is maximized. This also means less chance of the firefighter getting burned in case the fire does not come in control. Fourthly, the ideal distance for firefighting is the distance from fire where you are absolutely safe. It should not be too less so that you are in harm's way, not so far that the extinguishing agent does not reach the fire surface. So we can say that the ideal distance is where the firefighter is out of harm's way and the extinguisher can reach the fire surface, and the coverage of the extinguisher is most at the point where it touches the fire surface. Fifth, lastly, while firefighting never enter an extinguished fire zone, as a reignition or a weakened structure can put you in harm's way. Fire spreads and grows exponentially. In minutes, a fire becomes so big that thousands of kilograms of extinguisher is needed to put it out. The first few minutes is all that is there to douse the fire. Let us take a closer look at the importance of time while trying to extinguish a fire. With every passing minute, the intensity of fire grows geometrically. So does the amount of extinguishing agent required to douse it. For a extinguisher to be effective, it should attack the fire and extinguish it within 5 to 6 minutes. Beyond this time, only sophisticated sprinkler systems can be used to extinguish the fire. But after a point of time when the fire goes completely out of control, you can only rely on the fire brigade to help you. ABC powder extinguishing agent. ABC, as the name suggests, is a versatile extinguishing agent that works on most classes of fires, A, B, C and electrically started fires. This saves you a lot of time and helps fight multiple classes fire, reducing your losses. Let us understand how your extinguisher does that. Firefighting action of ABC extinguishing agent can be explained in 4 steps. Step 1. Inhibition. This is about breaking the chain chemical reaction in the fire. As the powder enters the fire, the particles interact with volatile hydrogen atoms, turning them non-volatile. Step 2. Smothering. This happens when the fire is penetrated with a cloud of powder. The fire gets diminished oxygen supply and reduces the radiating heat effect. Step 3. Cooling. As the powder settles at the base of the fire, it melts, absorbing large amount of heat from the fire source, thus cooling the fuel. Quantity of powder required is proportional to the heat content of the fire. Step 4. Starvation. Finally, as the melted powder forms a layer on top of the fuel, it virtually isolates fuel from surrounding atmosphere.